Chapter 8, Quantities in Chemical Reactions. I am skipping section 8.1. We're a little behind, and that is interesting, but not really necessary to understand this chapter, so I'm just skipping that. We're going to start with section 2, making pancakes. Yeah. This makes my 7 a.m. class very hungry. The numerical relationship between chemical quantities in a balanced chemical equation is called reaction stoichiometry. Stoichiometry. So that's a big long word. And it just means we're looking at the relationships in that chemical equation based on numbers. So we're measuring things. And this is really important because this allows us to predict, well, if I have this mass of starting material, what mass of product can I make? And so it makes chemistry very practical. This is a very, very important chapter, okay? These calculations are central to chemistry. This is a major part of chemistry, so this one's really important. The other thing I need to tell you is the stuff we learned, I think it was chapter 2, about dimensional analysis. This is the big chapter where we really need to understand dimensional analysis. So let's look at a very simple recipe for pancakes. I would not advise trying this at home. It's been simplified and it's not going to work all that well. I've made pancakes and this isn't how you do it, but it's close enough for this purpose. So the recipe gives numerical relationships between the ingredients. Here we have flour, eggs, and baking powder, and the amount of product that we're going to get. If we have 1 cup of flour and 2 eggs and half a teaspoon of baking powder, we can make 5 pancakes. If you only have 1 egg, you can't make 5 pancakes. This is the relationship, and it's given in the recipe. A chemical equation is a lot like a recipe. So here again is our recipe. And we can see from this that if we have 2 eggs and enough of everything else, we can make 5 pancakes. There is a relationship there, 2 eggs to 5 pancakes. So that's writing it as a ratio. We can also write it as a conversion factor. We can write 2 eggs per 5 pancakes. Pancakes. Or we could say 5 pancakes. It's easier to say than it is to write. 5 pancakes per 2 eggs. So this relationship, this recipe, gives us conversion factors. What if we have 8 eggs, not 2? And we've got enough of everything else, how many pancakes can we make? Well, you can make 20, and the picture tells you. You're also probably able to just think about this, and you're thinking, well, 2 eggs, 8 eggs is 4 times that, and so I'm going to make 4 times as many pancakes. That works really well for things that you're familiar with. But if we're talking about grams of hydrogen and how many grams of water are going to be produced, it doesn't work so well. So on this simple example where we understand what's going on, we're going to learn how to do the math so that we can do it on a more difficult example. So we have 8 eggs. And basically this comes down to unit conversion. I have 8 eggs and I want to know how many pancakes. So my path is going to be eggs to pancakes. So then I'm going to use a conversion factor, and I'm going to have pancakes up here. And eggs down there. So I'm putting the units in here so that they work out, and I'm going to cross out the eggs. The relationship between pancakes and eggs comes from the recipe. I can make 5 pancakes for every 2 eggs. So 5 and 2, and then I do the math, 8 times 5 divided by 2, I get 20 pancakes. Do you see how I did that? Okay, this is dimensional analysis, just applied in a different way. The units are going to tell us what to do, and we're going to use balanced chemical equations to give us relationships. Any questions yet?